Okay, so next up is the factory method. So the problem that we're trying to solve with the factory design pattern is um, when you want to create objects without specifying the class of the object that will be created. So imagine a car factory where you will provide the specifications, right? How many wheels, body type and all, and then the factory builds a car based on those specifications that you have provided, right? So similarly, we want to centralize the object creation uh, to simplify object management and decouple client code from concrete classes, meaning that whenever you want to create a object from a class, uh, the object creation will not happen when the place where you want to create when the place where you want to have this class or the object, it will be created in a separate uh, place, and it will be delivered to you based on the specifications that you have given as parameters, right? So to implement this, we need to define an interface or an abstract class or a base class for the product or other whatever the class, and then uh, based on based on that main class, you have to create concrete classes which will inherit that base class or implement the interface you created. Depends on whether you have created an interface or a class. If it is a class that you have created for the base class, then you have to inherit it. Otherwise, you have to implement the interface if it is an interface. So it is whatever that is, then you have to create the factory class, which is responsible for creating instances based out of those concrete classes. So what class, what is the object which will be created will be based on the input parameters that you are going to specify. Right, we will see that into implementation. So the factory method is used to do that, right? Right. So the factory pattern is used to create objects without specifying the exact class of object that will be created. So that is the takeaway from the for the question, what does the factory method is responsible for, right? Okay, so as I mentioned, think of this as a car factory where you want to create a car based on the given input parameters. So let's switch to the code. So here you can see we have the abstract class called vehicle, and it has uh, abstract method called drive, right? This could be an interface as well, as I mentioned earlier. So now you want to do in this case is we have two types of vehicles. One is car, the next one is bike. So based on some parameters that we are going to give, we'll need to the factory method is responsible for creating either bike or a car, right? So let's first of all um, inherit from the vehicle class, then we'll override this method which says drive, and inside the implementation of this drive method, we'll say we are driving a car, right? So only thing we have done in, we have inherited this vehicle class and we have overridden this drive method in that parent class, and then we have provided the implementation saying it is just printing to the console saying driving a car. So now what happens is we need to do the same for the bike class and provide the implementation for that drive method inside the bike class. So here we will say riding a bike, right? Very simple. Now we need to create the factory class, right? Vehicle factory. So it will have a create vehicle method, and we will, as the parameter, we will provide the type of the vehicle that we want to create. So if the type is a car, then what we'll do is we'll return a car object, right? And if it is the bike type, then we will return a new bike. We are creating an object using new keyword. And if it is anything else, we'll throw an exception saying this is an invalid vehicle type, right? So now how to use this factory? We'll have to create an object from the vehicle factory and provide the type that we want. It is very simple. Let's go to the program CS file and let's do this. We'll create a object from the vehicle factory, right? And then we'll create, we'll call the create vehicle method in that factory. We'll specify what is the type that we want to create. The vehicle 1 will be a car, then we'll create another vehicle, vehicle 2. Vehicle 2 will be a bike. So if you hover over this create vehicle method, you can see that it has a return type of vehicle. It doesn't say car or bike or any other vehicle, it will be a vehicle, but the type is specified by the parameter that we have provided into this factory method. So therefore it will decide what is the object that we are asking for. So we will call the drive method of both of those um, objects, and we'll see. Right now we'll execute this code using .NET Run. Okay, first of all we get driving a car, then we are riding a bike. So this is how we are going to implement uh, the vehicle factory or other vehicle of factory design pattern, right? So now the thing is where to use this in a real world scenario is imagine you want to create a UI library. So uh, you might have buttons, text boxes, and radio buttons. Then you will have other text fields, right? Things like that, various labels. As in a UI library, you will have multiple components. So you can use a factory method to create whatever the component that you need. So if you want a button, then you can call a factory method in your factory class asking for a button. Then it will create a button. So if you want some sort of another element such as a maybe a radio button, then you just have to specify what is the saying you want a radio button, and then it will create a radio button. So likewise, in a in an enterprise application, you can implement a factory design pattern to do that as well. Right? There are various use cases. So yeah, the problem, the solution it has given to us is that using input parameters, we can control what is the object we are creating. Right? There can be multiple parameters, not just the type. There can be many parameters, there can be optional parameters, right? So depending on the parameter list that we are supporting to this factory method, it will provide us whatever the vehicle that we are asking for. So in this vehicle or other create vehicle factory method, we need to use that specified parameters to do whatever we want. So that implementation you have to do, but output we are getting is solely depends on what is the parameters that we have specified. So after implementing it, now we have encapsulated the object creation logic. So nobody can't see, sorry, nobody can't see how the objects are created because we have encapsulated it into the factory method, and it has provided the flexibility to change product creation without modifying client code, right? You don't have to worry about when you are in the program CS, you don't have to modify much of the implementation. You just have to change the parameter set we are supporting to this factory method, and it will, based on that, it will create a object, right? And but the issue is it can make code more complex with the introduction of multiple factory classes. So if in a real world scenario you don't have only two objects, and it will not have only one factory method, it will be having multiple factory methods like this, it will be having multiple factories like this, right? So therefore it will introduce some sort of a complexity to your code. It will introduce more lines to your code, right? And it will require modification to the factory when new products are added. So if we add a new type of a vehicle, maybe a bus or something, then we have to modify this. We need to add another else if statement to this factory method to cater that newly added vehicle. So that is actually going, I mean, that is conflicting with one of our solid principles. So I hope you guys have heard about solid principles. There's a principle called open closed principle, which is the second principle. It says that class should be opened, uh, should not be open for modification. So closed for modification, open for extension, right? So a class once created should not be modified. It should not be extended using other functionality which we'll have to implement, but it should not change the implementation, or rather it should not allow modifications to this class once created. So that is open closed principle. Open for extension, closed for modification. So in the future, if we introduce new few more vehicles, we'll have to modify this class. So it is conflicting with that open close principle, but anyway, that is a trade-off that you'll have to make if you are using the factory design pattern, right? So as a summary, it can increase the complexity and the size of the code, as you need to create separate factory classes or methods for each type of object. So that is the factory design pattern.